So for number 7, there's nothing we can simplify under the radical, so we break apart into 2. On top, we have 5th root of 3. On bottom, we have 5th root of 4. We want to get rid of the radical in the denominator. You need to complete this set in order for the radical to disappear. So I need 5 of a kind in order for the radical to be gone. So if right now we have 1, 4, you say to yourself, how many more do I need to complete that set? Well, if we need 5, we need 4 more 4s in order for the radical to be gone. So that's why we multiply by the 5th root of 4 raised to the 4th on top and bottom. So the 4 comes out because in the denominator you have the 5th root, there was nothing in front, but underneath you have a set of 4s, so that's why that comes out. On top, when you merge, there is nothing in front of both radicals. Underneath you have a 3, and you have 4 4s, 1, 2, 3, 4. If we need a set of 5, nothing comes out on top. Oh, just kidding, something does come out. But we can keep factoring the 4s. So if there's 4 4s, there's going to be 8 2s. 1, 2, 3, 4, 5, 6, 7, 8. So if we need a set of 5, we can take out a 2, and that comes here. And then what's left underneath, 2 times 2 times 2 times 3 becomes 24. Anything in front, we can simplify. They're both divisible by 2. So 2 divided by 2, that becomes a 1 on top. 4 divided by 2, that becomes a 2 on bottom. So we have 5th root of 24 over 2. Remember, what's under the radical and what's not under the radical, you cannot divide by 2. To add or subtract radicals, the index and what's under the radical need to be identical. They are not right now. They both have index 3, but this is a 5 and this is a 40, so currently you cannot add them. Break down to see if they are alike. So cube root of 5 doesn't break down. There's nothing that comes out underneath. However, when we break down the 40, we get 5 times 2 times 2 times 2. We need a set of 3, so that 2 comes out in front, and we're left with a 5 underneath. So they are like, plus or minus separates the terms. So I have 1 of the cube root of 5 plus 2 of the cube root of 5 means I have 3 of the cube root of 5. For number 9, if you know that f of x is 3x squared plus 1, when you're substituting, put inside parentheses. Then this plus comes down in between. You substitute g of x. This is the right side. This is what g of x is. Now for addition, you're technically distributing a positive 1. Bars come off, so you're combining like terms. 3x squared and another x squared is 4x squared. 1 and 4 is 5. So this is our final answer. The domain. Are there any restrictions on f of x? No. Are there any restrictions on g of x? No. Are there any restrictions on our final answer? No. The domain is all real numbers. You're saying, when you state domain, if you made a table, right, x has to do with domain. If you're making a table, what numbers are you allowed to plug in? And basically all reals means there's no restrictions. You can plug in any x value, will never get error undefined. For number 10, so p of x, remember when we insert, use parentheses, times 5x. Plus or minus separates parts or terms. Remember, 5x is one term. You're not going to break up the 5 and the x. So distribute 5x to both. So 5x times x is 5x squared. 5x times 2 is 10x. You cannot combine 5x squared and 10x. That's your final answer. There's no restrictions on p of x, m of x, or our final answer. So again, the domain is all reals. If you made a table, you can plug any number in for x. You will always get out an answer, whether it be 0, decimal, positive, or negative. So for number 11, on top in the numerator, this is h of x. h of x equaled 3 over x. M of x was equal to 5x. So we plug in. You can't have a fraction in a fraction. So then I always like to write what's in my numerator, so the top, whatever that may be, divided by the denominator, the bottom. There's nothing to simplify for either of these fractions. You change division to multiplication, you flip the fraction on the right, and we end up over here. So on top, 3 times 1 is 3. X times 5x becomes 5x squared. So h of x of m of x is equal to 3 over 5x squared. That's our answer. When we're asked for domain, though, you need to look first at h of x and say, are there any restrictions on this equation? Remember, when you have a radical with an even index, or when you have x in the denominator, those are usually the two red flags. So we see an x in the denominator. You always set what's in the denominator equal to 0 and solve. That becomes your target, so to speak, on the number line. You always need to test out that value, plug in. So if we test that out in our equation, if we plug in 0, we get undefined. If you ever get error or undefined, that means you're not shading. That means it is not included, so it's open circle. Plug in values on either side, any number. I'll plug in 4. 3 over 4, we get an answer, 0.75, that works. So we're going to shade over here. Let's try to plug in a number smaller, any number. We'll plug in -1. 3 over -1 is -3. Check, so we shade over there. So we say x cannot be 0. That's the restriction for h of x. If we look at the original equation, m of x equals 5x, there's no restrictions on that, right? That guy would be all reals. And then we have to look at our final answer and see if there's any restrictions on the final answer, any more I should say. So we see x in the denominator, so if we set the denominator equal to 0 and solve, we would get 0. Again, that would be a target on the number line. Ask yourself, can it be 0? So we plug in 0. So if we plug 0 in, we would get 3 over 5 times 0 squared, which would become 3 over 0, which would be an error. So it's going to be an open circle. Then can we plug in a number larger? Let's pick 1. 3 over 5 times 1 squared, we would get 3 over 5. Check. We're going to get answers on this side. Let's plug in -1. 3 over 5 times -1 squared is equal to 3 over 5 times 1, which is 3/5. Check, we'll get answers. So this restriction is x cannot be 0. So when you're stating the domain for the entire problem, you need to consider all restrictions that ever popped up. So the restrictions were x can't be 0 here, x can't be 0 here. So the domain, we say, is all numbers, just x cannot be 0. When you're stating the domain, you have to make sure for your final answer you state any restrictions that happen along the way.